Hi everyone. As serverless platforms mature, more and more sophisticated cloud-native applications are built with serverless technologies. In this video, I'll give a demonstration of a serverless OpenWhisk application. The application is a polyglot application with functions that have been developed with JavaScript, TypeScript, Java, and Kotlin. Just before I'll start with the demo, let me give you some more context. When I refer to serverless applications, I mean applications that use several, often a lot of different functions. These functions can be developed by different teams and might be reused in different applications. The functions are rather easy and stateless. The interesting question is how to build applications which handle the invocations of functions and the flows of data between the functions. The way OpenWhisk solves this is by providing an extension called Composer, which is also available as open source. Composer is a programming model for composing functions. This simple sample shows three functions. Based on the outcome of the authenticate function, either the welcome function or the login function is invoked. As you will see in the demo, applications can be defined with Composer either declaratively or programmatically via Node.js. In my sample application, I've used several programming languages because the bigger applications get, the more likely it is that you want to use different languages. For example, you might want to reuse existing code or libraries in serverless functions, or you want to leverage certain skills in your team. Additionally, certain languages might allow you to implement functions more efficiently. OpenWhisk supports several programming languages out of the box. In the sample, I've often used Docker, which might be important for your requirements as well. For example, with Docker, you can develop and test the same image locally, which is deployed onto the cloud. This minimizes the risk of running into issues due to different environments. Docker also allows you to use programming languages your cloud function provider doesn't support natively, or newer versions of languages and runtimes than the ones supported by your cloud function provider. Let's take a look at the sample application. It's a rather simple send notification application, which is triggered with a person ID and a subject. The first function returns the profile for the specific user with an email address and optionally a phone number. If the profile has a phone number, a text message is sent, otherwise an email. Okay, now the demo. This is the IBM Cloud Shell, which is an Electron-based application to manage your OpenWhisk applications. You can enter commands here, for example, app list, to get a list of all deployed OpenWhisk applications. Then you can click on a particular one, for example, send notification, to open the definition of this application. This brings up initially here this visualization tab, and let me try to explain what you see here. First of all, these yellow boxes, they represent JavaScript code, and these black rectangles, they are the OpenWhisk functions. As I said, the sample application here has three main functions: read person profile, send mail, and send text message. And in the easiest case, that's really all you need. You could pass all the data from start to end and it would work. I've used an approach here that is a little bit different because I wanted to make sure that these functions that contain the business logic, that they are loosely coupled and can be used in different contexts. So I've added three more functions, these transform functions here, here, and here, which make sure that the actual functions get the exact input they are expecting and only the input they are expecting. Now, one more thing here. I said the application is triggered with two parameters, the person ID and the subject. The person ID is used and required here in the read person profile function. The subject is only required in these later two. Now, these blue lines here ensure that all the data flows through the application and is available also for later functions. There are some more tabs here. For example, you can get the JSON representation of the complete application here. You can even go ahead and click on this symbol here to open up the application in edit mode. Let me enlarge this here a little bit. So now we have these two columns. This one contains the JavaScript, the Node.js code, and this one here again, the visualization. I could go ahead and change something here and deploy it directly from here or revert it back to previous versions. And obviously, and that's my preference, you could also use whatever text editor you like. So let me close this now, because in the next step, I want to invoke an application. So what I can do here is I copy the command app invoke, then the name of my application, send notification, and then I pass in two parameters. The first one is the person ID and Heidloff. The second one is the subject hello. So let me invoke the application now. And once the application has been run, the output is displayed here. For example, this is the output of the first function, read person profile, and this is the output of the last function, send email, because this was a user who does not have a phone number in his profile. To make it a little bit easier to read and understand what happened, there's this nice session flow tab. So this brings up a visualization similar to the previous one, but in this case, not the application definition, or not only the definition is displayed, but the session state. So here you can see that this was the path that has been taken. These two functions have not been invoked. You can also click on these functions here to get detailed information about the output of these functions. In this case, this is the result of the read person profile function, and you can even, and that's really important for developers, you can even see the logs of your function directly here within the IBM Cloud Shell. Next, let me invoke the same application again, but this time for another user, not in Heidloff, but let's say Mark. And Mark is a user who has a phone number in his profile. So this time, when I click on session flow, the other paths should be highlighted. There you go. The last thing I want to show is this really useful trace tab. So when I click on it, you can see all the different events that occurred and all the functions that have been invoked for this particular session. For example, this was the first transform function here, transform read person profile, then the actual read person profile function, then again a transform function, and then at the end the send text message function. And for every function you can see directly here how long it has taken. For example, the last one here, this is a Java, a Spring Boot application. This one took 4 milliseconds to execute. Let's take a look at the implementation of the functions. I've used Java, JavaScript, Kotlin, and TypeScript. For the transform functions, I've used JavaScript. This is the function transform send mail. I get a list of multiple email addresses and will take one of those and forward it basically to the actual send mail function. And in order to do that, I use a node module, JSON-Nator. And this is pretty useful because it essentially gives you XPath for JSON. So here I create an expression and then I simply evaluate it to read out the email address. So very easy and straightforward. Now let's take a look at the TypeScript implementation. In this case, I've used Docker because TypeScript is not supported out of the box by OpenWhisk. And the implementation is really easy. I'm using here the Express framework, and all you need to do is to implement one single endpoint, this run endpoint. I can read the input from the body field and then return some user profile information and send back some JSON. Again, very easy and straightforward. Now let's take a look how I can invoke it. When you switch to the debug tab, you can run this debug configuration. It starts Docker, there you go, and it attaches a remote debugger, which I will demonstrate in a second. So here's my terminal and I do a curl and this worked. Okay, and now to make it more exciting, I go to my run implementation, set a debug point, and again run it one more time with a curl command. And there you go, I'm in the debugger, I can step through it, I can do all the things you expect to be able to do in a debugger. I say continue, and this actually worked. To make it even better, I can go ahead and change something here. Let's say not Niklas, but Niklas2. I save the file, and here the node runtime within the Docker container is restarted so that when I invoke the curl command a third time, it stops in my changed code. I can continue, and my changes are directly in here. Where is it? It should say here, Niklas2. The last two functions, send mail and send text message, I've implemented with Java and Kotlin. And I won't go in much detail here in this video, but you can go to my GitHub and get the complete source code. I just want to highlight here in this video a couple of key points. In both cases, I'm using Docker, which means, as previously, that you need to implement a run endpoint. So in this case, I'm in the Eclipse IDE, I'm using Spring Boot, and I'm using here this request mapping annotation to convert the input into a Java object, and vice versa, I return a Java object which is converted into JSON. And in Kotlin, I'm using here the IntelliJ Community Edition IDE, and it looks kind of similar, but the code is much shorter. I'm using some of the Kotlin capabilities, for example, these data classes, and that makes it much easier to read the code and clearly also to maintain the code. And as previously, all you really have to do here is to implement the run endpoint. Okay, so that's all for today. You can find the slides on SlideShare and the complete source code here on GitHub. I hope you enjoyed it. Bye bye.